Welcome to Chapter 13 of Think Python for LC101. That is the last chapter of this first unit, the last chapter of this textbook. So we'll be heading into Unit 2 after this and moving away from Think Python into some more specific and directed instruction. So this is our last chance to do these exercises together here with Think Python. So let's sit down, let's get them done, and let's try to enjoy the process of learning here. So in chapter 13, we learned a little bit more about classes. We learned about how you can override certain internal functions like adding. We can override what Python wants to do with adding and create a way to add together our classes. For example, if we wanted to change our point class that we had defined in the last chapter, if we wanted to change it so that you could add 2 points together and you would get a new point resulted at the combination of where those points would meet when added together. So if I add in, -1, -2 to 5, 5, it should go to 4 and then 3. So it resulted in a new point of 4, 3, for example. We could totally do that. We could do the same thing for other built-in functions too, like we saw with repr for the string representation, overriding that function, and we can do all of that. And that's going to be really helpful. We're also going to use that to override our own classes when we start to do inheritance. So if we want to create a class that inherits from another class, a class that shares some common values with another class, but we want to change a couple of things or add a couple of things, we can add things onto the new class, the subclass that didn't exist in the old class, the super class. And we can also change some of the things that existed in the super class by overriding them in the subclass. And we saw that via the cat class example and the tiger class example and the house cat class example that we did in the chapter. So we saw that we can inherit from superclasses to subclasses, and we found that we can add new functions to those subclasses, and we found that we can override old functions from the superclasses to make them be a little bit different in the subclasses. And we also learned about sameness and how we can check for sameness within our classes, and how we can override those default values for sameness if we want to as well. So with all that said, let's get started on exercise 1. So exercise 1 is going to ask us to create a new class for a rectangle, and it's going to create a class for a rectangle taking 3 variables, 3 arguments for its constructor. It's going to take a point, which represents the point at the bottom left corner of the rectangle, and it's going to take a width, and it's going to take a height. So we're going to create a rectangle class that takes these 3 arguments for its initialization method, for its constructor method. We have to have our point definition in here simply because we're using a point inside of our rectangle, so we need to have point defined. So let's go ahead and do exactly that. Let's create a class called rectangle. And when you're creating classes, remember you don't need to call them like functions up here. You just do class rectangle and then colon. Give yourself an empty space there. And then get started on our constructor method, which is going to take self, obviously. We want to call it point. Let's call it corner. And let's call these just width and height. All right. So you can absolutely, and I know that we didn't do this with our class definitions up here, but you actually can simply use the same value names in your parameters, your constructor parameters, as you do for your internal variables. The only reason we didn't do that is because it can be confusing to read if you're setting self x and self y to x and y versus a init x and a init y. It makes it less clear, less explicit, but you absolutely can just use the same values here inside your initialization method, because technically self.corner is different than corner. It's a different variable, and technically self.width is different than width, and technically self.height is different from height. But because we are immediately discarding these three variables once we get outside of our constructor method, it won't cause any problems within our class to just use the same class name as our internal values. So if you were struggling with coming up with value names, variable names outside of your variable names for the parameters inside of your initialization method compared to variable names inside of your state, worry not. Generally speaking, it shouldn't cause any problems to do that. So that's all we need to do for this first exercise. We can print that we've created a rectangle. So let's create a rectangle really quick. So we'll call it rectangle R, and we'll create it at first we have to create it like this, and then we want to create it at a point at 3, 3 with a width of 5. Let's do 6 and a height of 5. And let's see what point they created. There's at 4, 5. Okay, so let's create ours at 4, 5 as well. And then we can print R, but it's going to print kind of useless garbage for us. It's going to tell us that, hey, this is a rectangle object. So to change that to make it readable, we would need to write our own, like we did up above for points, we need to write our own string representation function to override the string representation that gets built in with Python, which is, of course, this down here. So we need to overwrite that. So we can say corner and add in a string representation for the corner, which we already defined in our point function. So we can just do that. We have to do self.corner though. And then we want width plus string self.width. And we want, make sure I have my spaces right. And we want height. And we want string self.height. Okay. Now, when we print here, we should get corner x 4, y 5, width 6, height 5. Let's save it, run it. There we go. Corner x equals 4, y equals 5, width 6, height 5. There we go. We'll add in some extra commas here just to try to get this looking right. Run that. Okay, there we go. That looks better. Save my code. All right, and then I'm going to want to keep copying down my rectangle class into these lower functions below. Let's see what they did for their answer real quick, because they have one here. All right, so they have, we can see that their values here that they're using are a little bit different. They have location, where I use corner. It's fine. They have width and height here, and they use initialization variables for the parameter. Again, absolutely fine, but there's nothing wrong with not using those and using the same name as your values here. And then their string representation uses formatting, which is honestly probably better. I like, though, that our string representation actually includes its location and includes its corner in the actual printing of it, because it's helpful to know that information. So we will just go ahead and copy this for ourselves here, and we will head down to the next problem. Next problem wants us to add accessor methods, get width and get height. They're going to work the same way that get x and get y worked on our point class. So we can do that really easily. So just simply add into our rectangle class a get width function. And we will similarly get a get height function. That's all we need to do. I'm going to copy my class. I could write a test case to see if that works, but I know that's going to work. It's exactly the same as get x and get y. All we're doing is returning that internal value. So I'm going to save that and see there's no answer up here, so we don't need to look at how they did it. We could test it, but again, it's pretty self-evident that those are going to work. So if you're worried about it, write out a test case where you use get width and get height to return the height and width of a rectangle value. All right, we need to write an actual method now, not just an accessor method. We need to write a method called area that returns the area for any instance, any object of rectangle. So for example, calling r.area on rectangle r should result in an area of 50 because it has a width of 10 and a height of 5. Let's do exactly that. Enter down here below our point declaration, paste in our rectangle here, and go ahead and define area itself as returning the width. Always remember to put self in front of your internal access variables there. Self.width times self.height. Right, that's all we need to do. Let's see if it works. Save and run. And we get pass. Very good. Let's see what their answer looks like here. They did exactly the same thing. So that looks good. Okay, make sure that I copy this every time, which is annoying, but we do what we have to. So this time we're going to write a similar method called perimeter. That's going to find the perimeter of any rectangle. So a perimeter of rectangle R here should be 10 plus 10 plus 5 plus 5 equals 30. So let's do the same thing for R's. Go down below our point definition here, paste in our rectangle definition, and then, add in below area here a perimeter function. Again, does not take any values besides self, and return our width, make sure we spell it right, times 2 plus our height times 2. And save that. And run that. And we get a pass on that test function there. Sorry if I'm moving a little quick. It's just that these methods are not very difficult. So doing the accessor methods and the area method and the perimeter method, all that should be based on what we did in the last chapter, self-explanatory from now. So these are just kind of quick catch-up examples to try to get you back on track. Okay, so make sure that we copy our class. There we go. All right. In question 5, we need to write a transpose method in rectangle class that swaps the width and the height. So, for example, if a rectangle is has a width of 10 and a height of 5, and we transpose it, it should have a new width of 5 and a new height of 10. So this is a modifier function, a mutator method that's going to mutate the internal state of our rectangle. So with that in mind, write out your own, and I will get started pasting mine in down below here. And then I will write my own down here. So transpose self, again, doesn't take any other additional arguments. Doesn't take any additional arguments. So we don't need anything besides self. and then all we need to do, as we can see up here, is switch the width and the height around. So 10 becomes 5 and 5 becomes 10. So that's very, very simple. So all we need to do is swap those two internal values. So self.width needs to become self.height. Now we can't do it like this, as we've seen a million times before. We can't just do this. That it would be nice if we could, right? But that's not going to function correctly. We need, if we want to do it like that, we need a swap variable, a temporary variable that we can swap stuff around inside of. So we set swap equal to self.width, and then we set self.width equal to self.height, and then we set self.height equal to swap, and that should transpose it. And then we don't need any return values because we're simply changing the internal states. So run, save it, run it, and it passes. Notice that I did not use self.swap here. We don't need to use self dot in front of every variable that we use inside of a class. The only thing that we use self dot for is for variables that exist inside of our internal state here. Swap is a temporary variable that technically, even though it exists inside of this method, which exists inside of this class, it isn't like a variable that's going to reoccur in the way that width and height and corner do. So because we've created those inside the internal state, they're going to exist as long as the object exists. So until we, delete the object, essentially, self.corner, self.width, and self.height are going to be variables that exist inside of this object until we're finished with it. Whereas swap is going to disappear the moment that transpose finishes. So make note of that. I also, really quickly, because I don't think I've covered this anywhere else before, cover a little trick that we can do in Python, because Python supports, as we learned in chapter 11, supports a value type called tuples. And so because Python supports tuples, we can actually do swapping of two variables a little bit easier in Python. We can actually do something like this. A tuple of self.width, comma, self.height gets assigned to the tuple self.height and self.width. And you can do this with any two variables that you want to switch around. So if you want to switch, two values, x and y, you can do x comma y equals y comma x, and it works in Python exactly the same way, because as you see we still pass because of the way that tuples work. So it's a quick, easy way to change the way that we've been doing swap in the past with our three variables. We can do the same thing using tuples, and that doesn't cause any problems whatsoever in Python to do it that way. So if you want another new quick trick in Python here, you can use that to kind of simplify your code a little bit. And I think it's still exactly as explicit as the way that we did it before with the swap variable. In fact, it may be more clear what we're doing versus using a swap variable when we use tuples to switch around like this. Let's see, how long has this video been? About 20 minutes. Yikes. These next few are pretty difficult in comparison to the ones that we've done so far, so I'm going to cover them in the next video. But go ahead and get started on them, see if you can knock them out before I get there.